phenomena that make physicists question the laws of nature. Imagine dedicating your entire life to understanding the fundamental laws that govern our universe, only to witness phenomena that make those laws crumble before your eyes. Today, we're exploring the most mind-bending discoveries that have left the world's most brilliant physicists questioning everything they thought they knew about reality. These aren't theoretical concepts or mathematical abstractions. These are real, documented phenomena that defy our most basic understanding of how the universe operates. Prepare to have your perception of reality fundamentally challenged. In 1982, physicist Alain Aspect's experiments proved that Einstein was wrong about what he called spooky action at a distance. Quantum entanglement, the phenomenon where particles remain mysteriously connected regardless of the distance separating them, was supposed to be limited to the microscopic quantum realm. But recent discoveries have shattered that assumption completely. In 2019, researchers at the University of Glasgow achieved quantum entanglement between objects visible to the naked eye. They entangled two tiny drums made of silicon nitride, each containing trillions of atoms. When one drum vibrated, the other responded instantaneously, despite being completely isolated from any physical connection. The implications sent shockwaves through the physics community. But here's where it gets truly disturbing. Classified military research suggests that quantum entanglement has been observed in biological systems and even larger structures. Dr. Stuart Hameroff's research into quantum processes in human consciousness indicates that our brains might be quantum computers operating through entangled microtubules. If consciousness itself operates through quantum entanglement, then our thoughts and awareness might be fundamentally connected to the fabric of space-time itself. The most terrifying possibility? Some researchers theorize that quantum entanglement might explain psychic phenomena, telepathy, and remote viewing. If human consciousness can become entangled with distant objects or other minds, then the boundary between individual awareness and universal consciousness begins to dissolve. Physics professors who spent decades teaching that such phenomena were impossible now find themselves confronting experimental evidence that challenges the very foundation of material science. Traditional physics assumes locality, that objects are only directly influenced by their immediate surroundings. Quantum entanglement destroys that assumption, suggesting that separation might be an illusion, and that the universe might be fundamentally interconnected in ways that make individual identity meaningless. Einstein's theory of relativity predicts that time moves differently depending on speed and gravitational fields. This has been confirmed countless times through atomic clocks on airplanes and satellites. But recent discoveries have revealed time anomalies that Einstein's equations cannot explain, phenomena so bizarre that they're forcing physicists to consider that time itself might not behave as we think it does. In 2018, researchers at the National Institute of Standards and Technology discovered that atomic clocks separated by just 1 meter showed different time rates, even when accounting for gravitational effects. The difference was microscopic, but measurable, suggesting that time flows differently in spaces that should be identical according to Einstein's field equations. Even more disturbing are the temporal anomalies reported in high-energy physics experiments. Particle accelerators occasionally produce results that appear to violate causality, effects occurring before their causes. These retrocausal events happen rarely, but they're documented and repeatable. Particles seem to be influenced by measurements that haven't been made yet, as if the future is reaching backward to affect the past. The Philadelphia experiment, long dismissed as urban legend, might have basis in classified research into electromagnetic fields and their effects on space-time. Declassified documents suggest that military researchers have achieved localized time dilation effects using rotating magnetic fields and superconducting materials. If true, these experiments demonstrate that time can be manipulated using technology not just theoretical physics. Dr. Ronald Mallett's research into time travel using rotating light beams has produced preliminary evidence that closed time-like curves might be achievable with current technology. His equations suggest that information could be sent backward in time using twisted laser light, creating paradoxes that shouldn't be possible in our understanding of causality. These temporal anomalies suggest that time might not be the linear, uniform dimension we assume it to be. Instead, time might be malleable, layered, or even capable of flowing in multiple directions simultaneously. For physicists trained to think of time as a fundamental constant, these discoveries are nothing less than terrifying. The measurement problem in quantum mechanics has haunted physicists for nearly a century. According to quantum theory, particles exist in superposition, multiple states simultaneously, until they're observed. The act of measurement supposedly collapses the wave function, forcing the particle to choose a specific state. But new research suggests that consciousness itself might be the mechanism that collapses quantum reality, implying that mind and matter are fundamentally connected. The delayed choice quantum eraser experiments, first proposed by John Wheeler, demonstrate that the decision to measure a particle's properties can retroactively determine its behavior, even after the particle has already interacted with a detector. This suggests that conscious observation doesn't just reveal reality, it literally creates it by choosing which version of reality becomes real. Dr. Dean Radin's experiments at the Institute of Noetic Sciences have shown that human intention can measurably influence quantum random number generators. Test subjects who focus their attention on these devices can bias their output beyond statistical significance, suggesting that consciousness directly affects quantum processes. These results have been replicated in laboratories worldwide, yet mainstream physics continues to ignore their implications. The Global Consciousness Project, based at Princeton University, has documented correlations between major world events and the behavior of random number generators distributed globally. During events that capture worldwide attention, like 9/11, natural disasters, or major celebrations, these quantum devices show non-random patterns that suggest human consciousness might create measurable effects in the quantum field. Perhaps most disturbing are the implications for reality itself. If consciousness collapses quantum superpositions, then the physical universe might not exist independently of observation. Reality might be a collaborative creation between consciousness and quantum possibilities, with each conscious observer literally choosing which version of the universe becomes real through the act of observation. This phenomenon suggests that the boundary between subjective experience and objective reality might be an illusion. If consciousness shapes reality at the quantum level, then the universe might be more like a participatory creation than a mechanical system operating according to fixed laws. For physicists who dedicated their careers to discovering objective truths about an independent reality, this possibility represents a complete paradigm collapse. Quantum field theory predicts that empty space isn't really empty. It's filled with quantum fluctuations that create a background energy called zero-point energy. Theoretical calculations suggest this energy density should be enormous, potentially infinite. But recent experiments have begun to harness this energy in ways that challenge our understanding of thermodynamics and conservation laws. The Casimir effect demonstrates that zero-point energy produces measurable forces between closely spaced metal plates. But researchers like Dr. Harold Puthoff have taken this further, developing devices that seem to extract usable energy from quantum vacuum fluctuations. These experiments suggest that the energy content of empty space might be accessible using resonance techniques and specially designed cavities. NASA's EagleWorks laboratory has investigated the M-Drive, a controversial propulsion system that appears to generate thrust without expelling reaction mass, violating Newton's third law. While skeptics argue that the measured thrust comes from experimental errors, some researchers theorize that the device might be interacting with quantum vacuum fluctuations to to produce momentum transfer with the zero-point field. Even more revolutionary are reports of over-unity devices that output more energy than they consume. While mainstream physics dismisses these as perpetual motion machines, some researchers argue that they might be tapping into zero-point energy rather than creating energy from nothing. If vacuum energy can be harvested efficiently, it would represent an unlimited energy source that could power civilization indefinitely. The implications extend beyond energy production. If zero-point energy can be manipulated and extracted, it suggests that the quantum vacuum isn't just a passive background, but an active medium that can be engineered. This opens possibilities for technologies that operate by modifying the properties of empty space itself, anti-gravity systems, faster-than-light communication, and space-time manipulation devices. These phenomena challenge the first law of thermodynamics, which states that energy cannot be created or destroyed. If zero-point energy can be extracted from empty space, then the universe might contain infinite energy reserves hidden in the quantum foam. For physicists trained to think of energy conservation as an absolute law, these discoveries represent a fundamental crisis in understanding. Einstein's special relativity establishes that nothing can travel faster than light, making faster-than-light communication theoretically impossible. But quantum mechanics reveals phenomena that seem to transmit information instantaneously across any distance, creating paradoxes that force physicists to question the fundamental structure of space-time itself. Quantum tunneling experiments have measured particles appearing to travel faster than light through potential barriers. Dr. Lijun Wang's experiments at NEC Research Institute demonstrated light pulses traveling at 310 times the speed of light through specially prepared cesium vapor. While mainstream physics explains this as a group velocity effect that doesn't violate relativity, the implications for information transfer remain controversial. The quantum Zeno effect and anti-Zeno effect demonstrate that the act of measurement can speed up or slow down quantum processes, seemingly allowing information about future measurements to influence present quantum states. This suggests that information might flow backward in time, creating causal loops that shouldn't exist according to relativistic physics. Research into quantum teleportation has achieved instantaneous transfer of quantum states across increasing distances. Chinese researchers have successfully teleported quantum information between ground stations and satellites, demonstrating that quantum entanglement can maintain instantaneous correlations across thousands of kilometers. While no matter or energy travels faster than light, the quantum information transfer appears to be truly instantaneous. The most disturbing implications come from research into consciousness and remote viewing. If human awareness can access distant information instantaneously, as suggested by decades of parapsychological research, then consciousness might operate through mechanisms that transcend space-time limitations. This would make human minds fundamentally non-local entities, capable of accessing information from anywhere in the universe instantaneously. These phenomena suggest that information might be more fundamental than matter or energy, and that the speed of light limitation might apply only to physical objects, not to information transfer itself. If consciousness operates through quantum non-locality, then individual minds might be connected to a universal information field that transcends space-time boundaries. Throughout the world, researchers have documented geographical locations where the normal laws of physics appear to be suspended or altered. These areas, sometimes called anomaly zones, display gravitational irregularities, electromagnetic disturbances, and temporal anomalies that suggest local modifications to the fundamental constants of nature. The Oregon vortex in Gold Hill, Oregon, demonstrates gravitational anomalies where objects appear to roll uphill, pendulums swing in impossible directions, and human height appears to change depending on position. While skeptics attribute these effects to optical illusions, precise measurements reveal genuine gravitational variations that cannot be explained by local geological features. Skinwalker Ranch in Utah has become a focal point for reality fluctuation research. Scientists have documented electromagnetic anomalies, gravitational irregularities, and what appear to be space-time distortions within the ranch boundaries. Animals display impossible behaviors, electronic equipment malfunctions in specific patterns, and witnesses report encounters with phenomena that seem to violate multiple physical laws simultaneously. The Hessdalen Valley in Norway has been the site of persistent light phenomena that display characteristics suggesting they might be naturally occurring plasma formations with anomalous properties. These lights respond to human presence, emit electromagnetic signatures that don't match known plasma physics, and appear to demonstrate primitive intelligence or responsiveness. Russian researchers have documented similar anomaly zones throughout Siberia, areas where compasses spin wildly, gravity appears reduced, and time flows differently according to atomic clock measurements. Some theories suggest these zones result from interaction between Earth's magnetic field and cosmic radiation, creating localized modifications to space-time geometry. The most disturbing possibility is that these anomaly zones represent natural laboratories where the fundamental constants of physics become variable. If the strength of gravity, the speed of light, or the fine structure constant can vary geographically, then our assumption of universal physical laws might be fundamentally incorrect. Reality itself might be more fluid and variable than we've ever imagined. These phenomena represent more than just scientific curiosities or unexplained anomalies. They represent fundamental challenges to the entire framework of modern physics. Each discovery forces us to confront the possibility that our most basic assumptions about reality, consciousness, time, space, and the nature of existence itself might be completely wrong. The implications are staggering. If consciousness shapes reality, then individual observers are co-creators of the universe rather than passive witnesses to predetermined events. If quantum entanglement operates at macro scales, then separation and individuality might be illusions. If time can flow backward and information can travel instantaneously, then causality and locality become meaningless concepts. These discoveries aren't just expanding our knowledge, they're demolishing the conceptual foundations upon which all of modern science is built. Physics professors who spend decades teaching students about objective reality, linear time, and universal laws now find themselves confronting evidence that these concepts might be fundamentally flawed. The crisis in physics is deeper than most people realize. We're not just discovering new phenomena, we're discovering that the nature of reality itself might be completely different from everything we've been taught. The universe might be participatory rather than mechanical, conscious rather than unconscious, and fundamentally interconnected rather than composed of separate objects interacting through forces. We stand at the threshold of a scientific revolution that will make the quantum revolution of the early 20th century look like a minor adjustment. These phenomena aren't going away. They're accumulating, strengthening, and forcing the physics community to confront the possibility that our entire understanding of reality needs to be rebuilt from the ground up. The question is whether we'll embrace these discoveries and follow them wherever they lead, even if they challenge our most fundamental beliefs about the nature of existence, or whether we'll continue clinging to outdated paradigms that can no longer account for the growing mountain of evidence that reality is far stranger and more wonderful than we ever imagined. Every like on this video supports the scientific courage needed to explore phenomena that challenge established paradigms. Every subscription builds a community of individuals committed to following evidence wherever it leads, regardless of how uncomfortable the implications might be. Every comment sharing your own experiences or research contributes to a growing recognition that reality itself might be more mysterious and participatory than mainstream science admits. The physicists who are brave enough to study these phenomena face career risks, funding challenges, and ridicule from colleagues invested in maintaining traditional paradigms. But they're also participating in what might be the most important scientific revolution in human history: the discovery that consciousness, reality, and the physical universe are far more interconnected than we ever dared to imagine. Subscribe to this channel if you believe that scientific truth is more important than scientific comfort. Hit the like button if you want to see more evidence that challenges our fundamental assumptions about reality. Comment below with your own experiences of phenomena that don't fit conventional explanations. The future of physics depends on our willingness to follow the evidence, even when it leads us to conclusions that transform our understanding of what it means to be conscious beings in a conscious universe. The revolution has already begun. The only question is whether you'll be part of discovering what reality really is, beyond the limitations of outdated scientific paradigms. Join us in exploring the phenomena that are rewriting the laws of nature themselves.